we actually have a lot of Apache Iceberg's users in the StarRocks community, right? They use Iceberg with StarRocks, and they will run into performance issues. And first, I want to kind of share some tips that works for the Apache Iceberg users in the StarRocks community that might also work for you, right? So how to tune Iceberg for demanding analytics workloads. So first is metadata rewrite, right? So manifest files either is too big or is too small. It's never really great for query engines planning, right? For to read the metadata, right? If it's too big, especially when there's not enough of them, the query engine cannot really parallelize the reading, right? Parallelize the reading, so it becomes slow, right? When it's too small, the planning phase becomes very slow because actually fetching the metadata files becomes a slow process, right? It's always easier to read bigger files than smaller files, right? And you always want to do a metadata rewrite or a manifest rewrite in Apache Iceberg, right? And what it also does is that it groups the data that's belong to the same partition into the same manifest. So actually, when the query engine does the data pruning, it can read less manifest, which also speed up the planning phase, right? So first is the metadata, and second is around data compaction, right? After you ingest your data, it's not done. You have to care the data, all the way through for it to have great performance, right? Although Apache Iceberg tries its best to keep, the data files size to some degree, but it can, it can be a small file scattered around when you have, for example, when you have highly concurrent write into different partitions, right? And especially when your write is very frequent and each batch is pretty small, it's small. So it's very easy to get small files, data files scattered around. A small file is horrible for data scanning, on the query engine side. First, it's because opening files is actually pretty expensive. So you have the same amount of data. If, say, you have the same size of the data, right? It's in 10,000 files versus 1,000 files. It's going to read faster on the 1,000 files, right? And also, this is kind of expensive too. There is a hidden cost, if you're using a cloud object storage. Let's say, for example, AWS 3, right? Every time, not the throughput, the amount of data, it's free, right? But every time you talk to S3 to get data, there's a charge there. So if your data is really not compacted correctly, there can be a lot of interaction between the query engine and S3, right? And you're going to be surprised at your S3 bill in the end, right? We have that happen for some of our StarRocks users as well, right? And also, small files can be even bad for planning because every data file you have, there is an entry in the metadata that stores it, right? That records the data file. So you can actually blow up the metadata file size, which is really not that good, right? And also, you want to learn and use Iceberg features, right? A lot of the features probably, they're not going to make your query run faster, but it's going to be easier for you to, for example, let's say do partitioning, right? Make the process easier, right? So that's great as well. And Apache Iceberg acts, in my opinion, it acts like a data warehouse on the data lake, right? It's a lot more like a data warehouse when compared to last generation data lakes such as Hive, right? So you really want to use it as a data warehouse. So all of the tricks, we use to accelerate the data warehouse queries, they still apply, in Apache Iceberg. Such as partitioning, sorting, right? Partitioning, you can read less data, right? Sorting, faster, right? And you want to distribute your data according to your own use case and your query workload, right? To make the queries run faster. And then finally, you have to choose the right query engine. So we talked about query planning. We talked about how to scan faster, right? Scan less data, data pruning. But query execution is almost dictated by the query engine. And not every, there's no query engine that can do it all, right? If you're running low latency, high concurrency workload on a batch query engine like Spark, you can engineer the hell out of it to squeeze out the last performance, but you're probably better off using something that's designed to run high concurrency, low latency data warehouse like workload, right? Like StarRocks. StarRocks and Apache Iceberg together presents a data lake house architecture that is really built for high concurrency, low latency query workloads. So I'll give a short introduction of StarRocks. StarRocks is a Linux Foundation open source project. It's a lakehouse SQL engine, query engine, right? It is purposely built for data warehouse like workloads. Actually, StarRocks got kind of famous because it was a real-time data warehouse, right? It's been handling data warehouse like workloads forever, right? Since it was open sourced, right? And especially when it pairs with Apache Iceberg, a lot of the features that were built for StarRocks as a data warehouse transitioned to open and standardized formats on the data lake really smoothly, right? So you get similar performance, even you're querying the data that's in the external storage, right? And also, StarRocks has a very simple architecture with no external dependencies, and it supports standard SQL and with Trino dialect. So if you're a Trino user coming from Trino to StarRocks, you don't really have to change your SQL, right? Just work out of box. So before I dive into the features or the details, I want to first present the performance of StarRocks, right? It's dedicated. It's built for data warehouse like workloads. So this is a benchmark comparing StarRocks to Trino on Apache Iceberg, right? So this is the TPCDS 1 terabyte benchmark test. So this test is really it's for it's emulates those like pretty complex ad hoc queries as well as ETL queries, right? So it's really complex with a lot of joins and a lot of high cardinality aggregations, right? And StarRocks 3.2 is almost 5 times as fast as Trino on JDK 21, right? Which is supposed to be taking advantage of all of the new features of JDK 21, like auto SIMD, right? But StarRocks is still almost 5 times faster than Trino, right?